What is a useful lifetime? Let's talk about something that most people buy, tires for their automobiles. Tire manufacturers publish the useful life of their tires in miles or kilometers, depending on where in the world you reside. But what does this number really mean? Take, for example, a tire which is rated for 60,000 miles. The tire manufacturer doesn't know exactly how the tire is going to be used, what type of driver will be using it, under what weather conditions it will be exposed, or how fast, slow, over what terrain or quality of roads it will be driven. Does a useful life mean that at 60,001 miles the tire will fail? Of course not. What it really means is that if used under normal conditions, there is a high degree of confidence that the tire will not fail before it reaches 60,000 miles. That's not to say that random failures won't occur, but if you continue to use the tire beyond 60,000 miles, it may be okay. It's just up to you to verify that the tire is still useful by periodically giving it a visual inspection to verify that adequate tread still exists. The useful life of many products, when charted over time, exhibit what is known as the bathtub curve. High failure rates occur during the infancy phase, followed by a steady state phase in which rates are low. As the product begins to age, the failure rates rise again. A steady state is typically the relevant range of the product's mission time. Safety-rated PLCs are required to publish failure data such as mean time to failure and the probability of failure on demand. These numbers are used as inputs to determine if a safety function meets the level required to mitigate the risk being controlled. IEC 61131-6 states that the useful life of a safety controller is assumed to be 20 years unless stated otherwise. The useful life is the relevant range of the system, and beyond this range, the failure data cannot be assumed to be constant. Calculating useful life beyond 20 years is nearly impossible, as electronics utilize thousands of individual components of which only the relevant range of failure data is known. And as we remember from our math classes, the accuracy of an equation is only as good as its inputs. Does that mean that safety systems will fail at 20 years? Does it mean that you should replace them at 20 years? Just like in the case of the tires, the answer is no. Safety systems, too, are installed in a variety of ways, from climate-controlled control rooms to outdoor high-heat environments. If a user continues to operate past 20 years, the failure rate should be monitored to verify that they are not increasing beyond the steady-state rates. It's possible to extend my tire's life by things such as driving responsibly and maintaining proper air pressure, and in a similar manner, proper oversight of your Triconic systems can enable them to deliver profitable safety beyond 20 years.